everybody, welcome back to another episode of The Skeleton Crew. I'm your host, Jen Callahan, and tonight I have with me Josephine. She's joining me from Australia, and she's coming in with a different perspective of using X-ray and CAT scan, and she's working for a company. She's the managing director of CJEL Digital Imaging. So Josephine, thank you so much for being here with me tonight, or today, I should say, because it's the daytime there.
Yeah, it's quite interesting seeing you got a long sleeve. I got a short. It's summer here.
Let's jump into this. So she's going to bring a perspective to us that we're not really looking at radiation from a perspective in healthcare mainly. I mean, what her research does can be applied into healthcare, but their research company is using it in other research capabilities. So Josephine, if you could maybe give a broad overview of what CJEL is and what your company does.
Yeah, we work with the two different folds. One part is that extensively relating with the research, so that rather than just taking an image, we're looking at perspective of uncertainty, how we make a more accurate prediction out of image itself. Mathematically, we estimate the clarity of what client want to know further than just image visualization. And then the second part, we does that with the young people. We're helping the young people when they graduate university, when they got uncertain and unclear about where their career would develop. We let them put it into the research project together with us. We train them. We work this research project to helping them to develop their career. And we actually had a couple of successful PhDs along the line. Yeah.
All right. So really twofold joint venture going on with CJEL. I was on your website earlier, and I like that CJEL stands for Communicate, Join, Educate, and Level Up. Am I right?
Yeah, that's right. That's the meaning, exactly. We found that people open, the benefit of work with the imaging industry, you visualize, you get a lot of insight, inspiration out of that. And you get imagination. There's a lot of commercial benefits, but more than that, to seeing what is going to happening without breaking samples is just fantastic. And 3D, 4D imaging and seeing the changes of the material from there, like without any intervention, it's just great. So people are quite happy with that. And we also found it's great for high school students to understand about science inside. So I don't know whether you saw the image of Tim Tam. Tim Tam is one of the chocolate Australia famous with. And inside the Tim Tam material, we got open the talks about this Tim Tam to the high school student when we want to promote the research and science. Then we're saying that, like, do you know why Tim Tam and two different Tim Tam taste different? Which one tastes good? How that surface affecting and things like that. So we're just showing this 3D images out of that, and they just so excited.
Well, what's the difference between the two? That you said the surface of them, it has something to do with the taste?
Yeah, when you got a lot of surface in there, because sometimes the merit is it's got chocolate outside, but inside crunch bit in there. When you see a lot of crust in there, and people when you bite it, inside of a lot of cracked particle rolling on the tongue, it makes taste fantastic. So that's one of the thing helping community project. But then we have even some like a biochar project. Biochar is the product. People now looking for the environmental concern, looking at promote the soil quality. So when you put it biochar underground, not only helping the carbon capturing, it also helping the pH and the temperature, also the humidity inside of soil and improve the quality. But the manufacturer of biochar, they like to know how good over the time. So rather than just taking an image, we do time-lapse imaging during that while continually dropping the water. So we had to set up special way from the acquisition and analysis. And then we have another side. People want to know how much gas, how much oil interacting inside of a rock. Then we take the rock imaging and we do dynamic imaging, but also we just mathematically calculate so that they know that what kinds of contamination can happen, what kinds of recovery can happen without actually experiment. They like one of the success story, we're so happy with it. It's just like really, really work so much harder to repeat it again and again to get high quality images. And out of that, we were suddenly able to take the prediction without so much hard, intensive days and days work from the images.
So the time lapse images that you're doing, what's the space between the imaging?
Oh, that depending on. So the biochar ones, they are the reactions. We first do prior analysis with we open engagement with the biologists in the cases or the material science engineering people. And then we identify how the reaction is happening. Often the reaction is faster within 24 hours. After that, it's slower. So we got from the prior, like every 15 minutes, and then we then slowing down to 2 hours, 3 hours, 6 hours, 12 hours, and 24 hours, 36 hours, something like that. But then we had another one like cement hydration. There was, I can't say the company name, but there was a big company wants to know how the hydration is happening, and we want to know really mechanics out of that. So then we just had to like recreate a terabyte imaging with the supercomputer facility. We just had to do very fast imaging every 15 minutes. Oh, it's just so difficult. It was really challenging because three staff together work overnight to make sure we can able to. Yeah, we were so excited about this. We haven't published yet. We're just preparing that, but it will come out. Yeah.
So what are you using for this imaging then? You said 2D, 3D, and 4D imaging. What type of machine are you using? Would it be like a CAT scan machine that you might possibly find in a hospital or like an outpatient healthcare setting? Or has it been modified?
Yeah, we're doing modified ones. We do bench-based one. We did actually involve our group is closely work with ANU and UNSW collaboration that had the spin up the company previously, and they were very successful in the resources company area to spin up the company and developing the software. Now, CJEL works particularly for go beyond that to work. I mean, we have initial work also done with the medical work area, but in a different steps. We will, for example, we looked at the bone, how the dance of the bone is important in a person. If you implementing part of bone to another structure, where is the rice ball? Those kinds of spatial analysis, we have done that too. And the muscle is another thing we are interested about, because if you're looking at the muscles structure carefully, it will also looking at the strength of the bone together. It will be more better for the patient as a doctor to understand what this patient need to be done to be truly to changing their life.
Well, sure. Just to give a little insight of what she's talking about, bone strength has a lot to do with muscle strength.
Exactly.
So
Yes.
if you take this and you relate it to, say, like a DEXA scan, which is looking at bone density, generally it's that type of scan is for a woman who is postmenopausal, but it's not only for women that's looking at bone strength. So it's being correlated with that. So you're looking at a person who might have really strong muscles, and I guess really they should have strong bones because
yeah, there's a lot of researches there. But what we're doing is that it's similar to the one of the publication we've done in the fiber. So we're looking at the direction of how the muscle lay down, and more than just the strength. So we're looking at it. So because our benefit is we can see the 3D structure to do more mathematical calculation. So we can more accurately predict that rather than just visual aspect.
Okay. And then when you were talking about looking at the bone and then inserting a powder type or something, would that be something possibly maybe along the lines of, say, a person who might have had like a kyphoplasty done for to one of their vertebrae in their spine? It's not powder bone, but cement is basically being injected into a bone to fix a fracture in the vertebrae. Would that be something along the lines of something that you're talking about?
Yeah, that's possible. It's just that at the moment, we are targeting a lot more educational aspect. So because we've just found that people are not quite aware about what can be done with imaging analysis. They think that imaging alone is just answer. just perfect to right answer. But the true fact is that really important that how to prepare sample, how to read and controlling taking your image itself, but also how you analyzing that. We actually do some samples doing two different acquisition to get clarity of material identification. There's a lot of things in there. And I find it really great to work with a lot of bright students that they see that what can be done more than just normal or just they doing research. It is very complementing existing research. For example, we had a case, people understand, the rocks, how the fluid moving into there. There's a typical experiment that people does doing MICP. From the MICP, they don't really understand why the heterogeneous rock, quite different homogeneous rock. But from visually, when you do simulate it and then also take the image, we can clearly understand why that is happening. And people see only micro, nano, it's just another challenge because our effect, we gotta be generalized about bigger sample, but at the same time, we need to understand clearly the nano and micro scale as well. So like really combine the research to able to us to understand nature and helping people.
It's interesting that you say that fluid goes into a rock, which is something that I would have never thought of.
Never thought.
I think of a rock, I just think of a solid mass that nothing is going in or coming out. It's interesting to hear that you say that they can be heterogeneous, that it's not just one form of matter, that something else can exist inside of it. I honestly would have never known that or even thought of that.
That was my PhD, that understand how the fluid move inside of rocks, how they interconnected and extract the geometry connectivity issues. Then you understand the contamination. It goes to, of course, application of soils, but it's a lot more in a different way because underground is not visible. You got to be a lot of working on heterogeneity and the homogeneity, alibi, larger sample. It's just, I don't know when it's finishing research. But we're making always good progress. This I know. So we know a lot more than what did know the 25 years ago. Yeah.
Okay. And you started your journey in this over 20 years ago. You said, did your PhD 25 years ago?
Yeah. I started, my background originally was chemical engineering. Then I did with resources engineering. Then the end of resources engineering, we were doubt about the ambiguity we have continuously. So we thought what might be if we develop ourselves electricity with really high resolution, and then whether we can ever really come up with a true answer that we have to do days experiment in the lab, and it worked.
This episode is brought to you by xraytech.org, the rad tech career resource. If you're considering a career in radiology, check out xraytech.org to get honest information on schools, degree options, career paths, and salaries. So the students that you have come into CJEL, you said that you have high school students, but do they range from high school all the way up to students who are doing postgraduate work?
We mainly work the postgraduate and graduate of undergraduate students who are interested about the imaging, who are interested about some of AI, machine learning, deep learning, those directions. So we particularly who likes to do, rather than just doing like when they're thinking about PhD, for example, if they come to us, we training them what kind of other capacity they could have. For example, we helping them to understand Unix, supercomputing, and we helping them to understand like huge data set handling. This is something everyone needs these days. And then we identify potential supervisor and work together. So they can publish before even they can start it. Means that they really want to do it. So they can really designing. And some of them actually went to the company at the end. They know, but they are good at it.
Great. So when they come on and they're coming in to do some research, are they joining a project that's already in the midst of being researched, or are they coming in with their own idea?
Most of them. Yes, some of them have an idea by their potential supervisor. Most of them actually we have a given project working with it, so that we can give them a choice to see what they're good at it. And then we can along the line modify for them. Yeah.
Okay.
Also, sometimes the company demanding, like if I got clients saying that, okay, they want this is particular, then I get consent to involving the young people so they can potentially have a staff to work together. Yeah. So they're very happy with it. Yeah.
Okay. What's the general length of time of one of your research studies that you do?
That's really depending on various, because some company doesn't want to reveal anything and just have to be silently work very, very fast as well. Then we always then involving then extra research staff or collaboration so that we make it ensure that we giving clear answers. And those it can be takes about 2 weeks to a year. Yeah, more than a year. But there is a process to, if the case was a student who published it, if we involving just conference paper, not a big problem. But if the publication is, only if we are allowed to publish, right? Then in that case, then we have to went through normal processing of reviewing and things like that. It can take like a few years to admit that, because reviewing and agree everyone to we get allowance to publish, not always easy.
All right. So just thinking about the equipment that you're using to do your research, I can only assume, just like the equipment that we use in radiology, that, your 2D, 3D, 4D imaging equipment has made quite advancements since you began your journey through research 25 years ago. Is it considerable, the change in technology that you're using from then till now?
A lot. For example, detector has developed hugely, so we can take a lot faster acquisition. We found that rather than just buying the company existing ones, if we modify, we can find even upgrading system. It works as well, so that detector speeds a lot faster, like clearer. It got automatic noise options. It happened, and also data processing as well. It's like before we had to use a lot of supercomputing facility. But these days, we can buy just local workstation to processing it. It wasn't possible in the past. Has a changed our software aspect as well. What I find when we started, everyone seems like we want new, but we were new kinds of, because we were intensively putting our effort to developing fast processing software and parallelization. And we had a lot of researchers involving work together. So back then seems like a very new, but suddenly these days I've noticed a lot of people doing it. It's like when you see that someone passed the 1 minute, like those kinds of barrier, then everyone can do it suddenly.
Yeah.
It's a good thing. Yeah.
Shorter processing times is huge, I think, across the board for anybody, even to this point now that I feel like you expect computers and technology to move so fast. And when it stalls and it stops moving, you're kind of like, why are you not moving faster? Because you become so impatient because you've just expected that things are just progressing like that. So
it's got to be faster because, for example, one of the projects with us is that now we are going to heading on to moving to a direction to customized software. For example, if they want to be only analyzing bones in a 2D, yes, we just put in a lot of input into it that already analyzed, and we train it. We just give them trained image, particularly for their sample, their info. Then it will be like a factor 100 times faster, just applying and get an answer immediately. So that's what we are going to moving on. We already done it, some case studies, and we do more. It will get more cost effective for everyone.
So talking about the advancements and the lapse of time, and having to do things quicker, what other challenges do you face within doing research for these different companies that are asking you to do the image analysis?
The main difficulty is fundings, because we gotta be somehow fairly pay this even the student they graduate, because we have a certain time they're training after we make sure they have to pay, and we also have to pay ourselves as well. And then we gotta be also satisfy our clients. So the funding is a big issue, but if the client is happy with the initial research and they put on it, we keep going on that. Yeah.
Okay. All right. And then obviously opportunistic for all parties involved. Everybody's learning something new, and then the client is
Exactly.
getting the answer of what they're looking for. Hopefully it's a positive answer of what they're looking for.
I mean, it's more than just a simple, because they would get staff, potential staff, trained people working together.
So where do you see, well, we were talking about AI. Have you been in the midst of any potential or current research studies, involving artificial intelligence? Could be
Yeah.
related to radiology or not even related to radiology.
It's not always easy to, from the visually of radiography image itself, to identify all the materials. But if we train them certain aspects of feature, it will able to detect automatically. So it's always more information allow us to get more close to the right answer and remove the uncertainty. And it's very interesting to see where the challenging goes on. But I'm actually thinking that people worry about their job losing more and more. It's true answer that it is true that people losing their job, some of people, but some of the people will gain the opportunity because of this. Say that imagine that rather than normal just having a radiologist degree and work with that, if you have additional research capacity, you would be able to be keep going on with your career, further developing always. That's why I found that our company will be even better for later on cases. And we will, once we can involving more students to testing our software, to more getting clearer, we can then part of software and commercialize from the even normal clinics. That's what we hope. But rather than we like to really focus on what we are good at it right now. And then we do step by step rather than just hushing it. Yeah.
So it's really interesting how you think of imaging as just related to, sometimes radiology or just, maybe in my mind, I'm thinking that because that's just really where my head is the majority of the time. So it's interesting to hear how, imaging analysis can be used in other senses, to do research of what you're talking about. What does CJEL have, in the works if you're able to share with it, any exciting new research that the company's doing?
Yeah, the current image that we are finalizing it, we are just processing of responding the reviewer come back. One of the nature journal we are going to getting into that was biodegradation of plastic material. So they got more natural plastic, which can be degraded faster. And we like to analyze, we have analyzed that how the 3D image analyzing the process of degradations. And we're just fascinated, can see it because often the researchers can see with a high resolution only 2D and they open it, break it. When you move out and they can't truly see how the degradation happening in nature, while we just took it as it is 3D. So with an initial study finished, we just about to publishing, we're just so excited. I'm happy to share that images with you. Yeah. And then the future, we like to more and more working that all the existing image analysis, we have done that. We make it automation to make it clarify so that everyone can use more easily and do further in-house research. So we can more customize in their own equipment because they have their own image sample you can provide us. We can work continually with young people. And I think the really future that our professional field work with research because that's really that's will not be overtaken by automation.
Yeah. Yeah. Even how you were talking about the AI. I mean, I've had this conversation with many different people who have come on that they work doing AI and incorporating it into the workflow, but it's not to take over anyone's job. It's just there to be an extra aid, maybe an extra pair of
That's right.
to help you, to help the human eye basically, or to make the workflow go better. It's not there to take over your job because honestly, I don't think computers can take over our jobs at all. They function with the input that we put into it, right?
Yeah, exactly. Also faster. And also it remove our error as well. Because human create error, right? We are creative at the same time error. When you do repeated work and collections, we can remove our errors through the AI. Yeah, there's a lot of advantage. And if you have enhancing of research capacity, then means you are not going to be normal radiologist. This is another advantage our company grow. Yeah.
Mhm. Well, Josephine, thank you so much for taking the time over there in the day and then in the evening here. So you enjoyed our conversation and, the different ways that image analysis can go. So thank you again, everybody. This is Josephine joining me from Australia from CJEL, doing image analysis on many different things, not just on bodies. And this is Skeleton Crew. So make sure you check us out for past and future episodes. And make sure you check out this one on Spotify, Apple Podcasts, and then also too on YouTube. So, all right, guys, this is Jen and Josephine.
Thank you.
You're welcome.
It was great talking with you.
You've been watching The Skeleton Crew, brought to you by xraytech.org. On the next episode, join us to explore the present and the future of the rad tech career in the field of radiology.